Welcome back, friends. Today, I'm looking at this small block Chevy 400 block, and I'm going to check the shape of the cylinders. This isn't measuring the cylinders. I'm going to do that in another video. Right now, I want to check for consistency from top to bottom down the bore. And I'm going to use this dial bore gauge for that. I've got it set up a little over the width of the bore, which is on this one 4.125 inches, and I did zero it out, but let's see if it's still in. But I want to show you how to do it. We're going to measure. You can measure this way, like parallel with the crank and the cam, and then you can turn it 90 and go that way. I'm kind of going to do it like diagonal, and it doesn't really matter. You can go just measure two 90-degree angles. And we're gonna, so I'm gonna stick this in here and see how much longer that is. So I shove it down and get it in there. You gotta get it in there long enough so that this thing is moving, right? The dial. And then as we rock this back and forth, so rocking like that, like this, right? When it gets to the widest diameter, it's gonna top out. So right now it's about, I have it set about at 0. Pull this up a little bit, and again, this isn't a measurement, this is just an indicator of consistency. So there's 0, right? It's topping out at 0 pretty much. That's right at the top, and then so we'll just call that 0, right? That's at 0. And now we're going to go down at about 1 inch in here, and this is just to get relative measurements. So there, see this one, oh, it's pretty close, right? Pretty much the same right there. We'll go down another inch or so. This one is, so that's a little over, right? That's like a half a thou over, because it's not getting compressed as much. So if the needle was getting compressed more, it would go past 0. But since that one was not at 0, not quite at 0, it means it's that diameter is a little wider. Let's go check down at the bottom. So that's about a half, yeah, way down there at the bottom of the stroke. All right, and then, so that's pretty good. That's like at the most a half a thou, which is totally within spec. And now let's go over here. We'll do the same thing from the other angle. And this will be easier to read. So we're at the top, we're at the oil ring area. Boom, boom, yeah. A little tiny bit wider this way, which is not uncommon. Most cylinder bores, as I understand it, are not totally round. So there we go. Almost, yeah, about a half a thou, and we'll go down a little farther. It's about right on the money, and then down to the bottom. And then pretty much on the money there, all the way down. So that's measuring the consistency of the cylinder, and that will give you write those numbers down. I didn't do it right now, but if you write these numbers down, and we could call this like set A, and set B, or you could call it parallel and perpendicular, whatever. You got 2 sets of, in this case, let's say 4 numbers, right? So 1 up here, 2, 3, 4. And it'll give you a picture, kind of the shape of the cylinder bore moving top to bottom. And you do that for the whole block. And then that will tell you really it's just going to tell you if the cylinder bores are pretty round and true, straight down, up and down. They don't have like a sand dial, shape or some other shape, barrel shape or something. This block I've checked, and they're all really close. They're all within 1,000th of each other, which is great. I also checked the deck with a feeler gauge, and I couldn't get anything 2 thousandths and below. I mean 2 thousandths and over. I could get a thou and a half. I have a feeler gauge, it's a thou and a half. That one I could slide under a couple spots, but that's totally within spec. The only other measurement which I will do to check the squareness of the block is where we put the crank back in, and we're going to put a connecting rod and a piston and go to top dead center on the 4 outer holes, and then we're going to see if those are all equal. And if those are all equal, then really this block does not need cylinder, bore, and deck machining. Although I'm not totally set on not doing the machining, because I still want to get the quench right, and we'll see. I don't know. I kind of want to spend the money somewhere else rather than spending, you know, $800 to $1,000 on a procedure that I may not need, but we'll see. Anyway, I hope you learned something. Remember, I'm just a guy in the side yard and the driveway doing stuff with tools. I'm not a professional mechanic, so you don't necessarily copy me or believe anything I say. I'm just doing some work, trying to help people like me out there. If you like it and you appreciate it, go ahead and give it a thumbs up. Subscribe if you want. I'll see you guys in another video. Thanks for watching.